have more moral victories these days than we do actually victories. I'm going to kind of hold off on that one. We'll get there one of these days, though. I did want to just highlight who Genera is. We are basically, in essence, a biomass supply chain services company. We manage biomass supply chains for a variety of players in the industry, and we typically focus on dedicated energy crops. So that would include short rotation woodies, like hybrid poplar and willow, but we also deal a lot with switchgrass, miscanthus, and corn stover, some of the other biomass residues, but typically on the agronomic production side of things. We also handle a lot of logistics, and even though Tom and I didn't coordinate today, he did a very, very good job in overviewing the harvesting side, so I'm going to focus a lot more on the logistical side. It is good to talk about trees. I'm a forester by background, but I have spent a tremendous amount of time in grasses here in the last little bit, so it's kind of good to get back to this. But I'm going to focus on what happens once we harvest that material. And I think one of the take-home messages that you should have from all of this, in hearing a lot of the speakers today, is that there's not one easy system. There's not one easy answer. It's going to be optimized for each application or project. You've heard about Zeachem, you know about Kior, the big name here in this part of the country. Different technologies, different processes, different feedstock specifications. It's going to drive everything that you do upstream in the woody crop production is going to be driven by that end user. And so you have to optimize your system for that user. Genera works with the biofuels companies. Obviously in this neck of the woods, Kior is the big name that you have here. But I would also stress that there are many others working in biofuels. There's some big commercial plants coming online here this year. There should be 4 up and running in the U.S. now. 2 of them are already open. And then there are other markets, though, that we also work with as well. So biopower, particularly institutional scale, hospitals, schools, that kind of thing. That's a pretty sizable market for biomass. And then another probably even larger one for us is the bioproduct side. Making advanced polymers, plastics, materials, and other products out of biomass. So you see folks like Coca-Cola with their plant bottle, Unilever, Nike, a lot of different folks like that aren't normal names that we bring up in this kind of sector, but they're the folks that are driving some huge market plays right now. There's a company called NatureWorks out there. They're making biodegradable plastic bags for grocery stores, and it's all being derived from biomass separated compounds. The market in bioproducts, the thing that I think sets it apart and the reason that we shouldn't leave it out, is it's not dependent on federal policy. A lot of the biofuels and biopower sectors that we work in are driven a lot by regulatory environments, whether it's greenhouse gas emissions, fuel security, those kinds of things, which are all very important. They're still driven by politics. And we all know how consistent Congress can be on policies and how that affects everything. The bioproducts, however, tend to be a very, very different sector and are more market-driven, more consumer-driven, and we see a huge demand right now for some of those products. So as you think about what these crops can be used for in the long term, I think it's really important to think about all the potential markets beyond just biofuels. We really do see the short rotation woody crops as being a valuable tool. In the last presentation there was quite a bit of discussion around timing of harvest. One of the things that we see as a business, that the ultimate successful biomass users will be able to use multiple feedstocks throughout the year. And what that allows them to do is to address seasonality issues. So for example, if you're producing switchgrass or one of the other herbaceous crops, you're going to harvest that typically in a very defined period of time, a 3 or 4 month window out of the year when it's dormant. Integrating that with something like wood, and let's say a biomass sorghum that's harvested green in the summer, you can deliver directly to the conversion facility out of the field about 8 or 9 months out of the year. That eliminates storage costs, it eliminates quality loss. There's all sorts of benefits to that that you get by having that seasonality. The nice thing about wood is that its season is typically very, very long. Even though you hear that some of the coppicing doesn't seem quite as effective during the July, August, that late winter standpoint, that still gives you 9 or 10 months of the year to harvest in. And that storage on the stump, that flexibility of harvest, makes wood in a very attractive crop. And we're working on a project in North Carolina right now that will use 4 different feedstocks, wood being one of those, and it's all because of that seasonality. It eliminates risk for them. It kind of diversifies the portfolio, if you will, and doesn't put all the eggs in one basket. So When we look at optimizing the biomass supply chain for a customer, we start with what their specifications are, what their technology drivers are, and they are very, very different. Whether it's an ash content or chlorine content or magnesium or potassium, you name it, there are a number of factors out there that each of these guys drive. We work with one customer, the one in North Carolina actually. They can take full-on wood chips. They're not going to hammer mill, they're not going to fine grind, so moisture doesn't matter. They can take green wood directly harvested out of the field with a forage harvester in these short rotations and dump it right in their process. Not an issue for them. That's a biochemical process. We work with another customer that's on the thermochem side, so combustion. Ash is a huge issue, but they like wood because the chlorine level is low. But there again is that clean chip requirement. So what do you have to do in the field to make sure you get a clean chip? It's potentially a longer rotation on some of these crops to get that to a size where you can debark it and other things. But the point being is that your end user drives everything that you do up through the feedstock chain. And so when we look at kind of picking up where Tom left off on the logistics of things, it's all about what you have to take out of the woods and how do you do it most effectively. Is it most effective to harvest roundwood and haul roundwood on a truck and have that processed somewhere else? That works in some cases. In many other cases, like I said, the forage harvester really works. And the one thing about the forage harvester that they talked about from Case New Holland is that same machine that they harvest willow and poplar with, we swap the heads out on it and we can harvest sorghum and corn in the summer, and we can harvest switchgrass and miscanthus in the winter with the same machine. We actually have run in Tennessee on switchgrass the very same machine that they ran on willows in New York. It's very, very multi-purpose. And so when you look at these blended supply chains with multiple feedstocks, you get to spread that equipment cost out over a variety of crops throughout the year, and it kind of addresses one of the problems that Tom brought up is how do you pay for that expensive equipment, so you can spread that out. But that end user drives how you bring it out of the woods. You know, there are some other methods that we've looked at from a logistics standpoint. You may have heard of some folks with a mobile pyrolysis unit. So they're actually turning the biomass into a kind of a sludge type oil in the field at field edge or at wood's edge and hauling that material. There's some promise to that. I think the economics aren't quite there yet, and there's some stability issues with that material from a quality standpoint. But the point is, I think there's lots of advancements we can make in the logistics side of things to help reduce cost over time as we move forward. I think it was Randy that recommended or talked about how early on we are in the crop development cycle for the genetics of this woody material. We're very early on. If you look at corn, the corn yield on average has increased about 2 bushels per acre per year for the last 50 years. You know, we've got corn farmers in the Midwest hitting 320 bushels this year with good rainfall. You know, if you compare a woody crop like the hybrid poplar and the cottonwoods that you see here, we're very early on in that cycle. There's a tremendous amount of improvement that will happen in the genetics, but a lot of that corn yield increase has been in the technology around harvesting and logistics and handling. And we've been able to make more effective use of what's out there as well, and I think you'll see the same thing. So whether it's a logistical method of more effective harvesting, you know, the forage harvester, in some of our plots we can actually drive the over-the-road truck right through the field with it, blow the chips into the truck, drive it straight onto the mill or to the conversion facility. In other situations we have to use a hopper wagon, dump that into the truck. There are lots of efficiencies to be gained there. We did a study with one of our customers this year with some bulk harvesting like that. What we did is we took the forage harvester through the field, loaded it directly from the forage harvester into the over-the-road truck, took that to our receiving facility, and by doing the just closer logistical management, same technology, nothing new, just closer logistical management, our harvesting costs were reduced by, or our transport and logistics costs, excuse me, were reduced by 14% compared to the year before. 14% doesn't sound like a lot, but on a few 100,000 tons a year, it's a huge difference. And that's just an example of the simple improvements that we're making today to help drive down that overall biomass cost for the end user, for the keywords, or for the combustion unit. The key thing there too, going back to the quality specifications of your end user, we have to coordinate very, very well with the customer. You know, depending on the type of material that you're delivering, whether it's chips or round wood, most of these end users don't have significant storage capabilities. In other words, they're not like the Bow Waters or the Resolutes, I guess, today, that have these just mountains of wood chips under their stacker reclaimers out there. Most of them are more limited than that. They'll keep a very limited supply on hand, just a few days at most. And so you have to coordinate very, very well with them. The other thing is they have to be able to keep up with your delivery rate. Some of these commercial biorefineries will consume over 1,000 tons a day. And how do they receive that many trucks effectively? The study that I talked about earlier, where we reduced cost by 14%, from the time the truck hit the scales coming in to the time he left on the scales to weigh out empty, averaged 7 minutes and I think 14 seconds. So he came in, was unloaded, and left in that amount of time. He didn't wait in line. We kept a steady flow of trucks. That kind of operation is critical to drive down cost. You can't have a line of trucks 25 deep out the road waiting to get across the scales and get unloaded. So that facility also has to be designed to take the volume that they say they need. We found that actually in a couple of customers to be a real bottleneck. They didn't think about the logistics of the material coming in. One of the things that you see with a lot of the bioconversion facilities is they're getting better about it now, but especially early on, they really didn't think about the upstream part. And how important it was. It wasn't a build it and they will come sort of thing. You've really got to plan this out all the way through. And so we focus very much on working with our customers on that receiving capability. It's a lot more complicated than just dumping out a load of chips or having a claw unload a load of round wood and stacking it out on the yard. When we start looking at biomass at some of these scales, and wood has some advantages here, simply because of its history as an industry, particularly from the pulp and paper side, of having some of these issues addressed, but it's still a little bit different when we start getting into some of the quality issues that these biomass conversion facilities have. So we look at, obviously trucking a lot of material. I think that's the key factor in wood. Depending on the type of material you're hauling, that'll drive the type of trailer. Field access is a big issue, and that's one thing that our traditional logging industry has been very, very good at. I've ridden many times with a logger with a load of logs on some road that I'm not sure I would have driven my personal pickup truck on, much less an 18-wheeler loaded with logs. So they're very, very good at getting access, but that is something that we have to be careful and address. A couple of the other transport items that we've looked at, particularly for large-scale facilities, is actually rail or barge transport of wood. We've seen that in some limited instances with other industries, but particularly for these facilities that need thousands and thousands of tons per week, you can greatly expand your supply shed, if you will, by incorporating rail and barge. The chip industry has been particularly good at accessing rail and using that to move hardwood chips around, particularly clean chips. Barge is actually the lowest carbon impact from a transportation standpoint. Typically it's very economical, but it requires the least energy per ton of any of the transports. And so we've actually looked here in the southeast, particularly with the Tennessee River system, the Tombigbee, and the Mississippi, about having bulk wood collection facilities at different points along the river, and then those ship more directly to an end user, particularly even in another state, and we can do that economically. So we see that as being a really feasible transport option. We actually see that in corn. In East Tennessee, actually about 20 miles from our facility, Tate and Lyle runs a corn syrup, corn ethanol facility, and they barge in every bit of corn that they use from the Midwest. They don't convert Tennessee corn, they barge it in on the Tennessee River system. So it can be quite economical. The other thing that we focus on transport, I mentioned earlier, is just the real key management focus on that. You need to be efficient in your dispatch and your management of your trucks and your transport system. We focus as a company, we have staff that are solely responsible for the dispatch and management of those trucking fleets, and it's all about keeping them spaced out. It's about the flow through the unloading facility and making sure that your harvesting machines continuously operate in the field. That's the other part. You don't want a harvester to sit and wait for a truck. That's never a good thing, and that adds cost to the system. The other key point that I want to cover to kind of add on to what Tom had talked about was some of the considerations at the end use point for some of these biomass materials, and wood is included in this. Even though that some of those receiving systems are developed, we focus a lot on quality control and safety around these systems. And anytime you deal with biomass, it doesn't matter whether it's wet wood or dry switchgrass or dried wood. There are lots of issues with handling that type of biomass. probably most of you who've ever been around wood chips or any other kind of ground biomass, even if you've chopped silage on a farm, you've seen bridging and rat holing issues in receiving bins. You know, you can dump a load of chips into a stacker reclaimer or receiving bin, and inevitably at some point they're going to bridge, which that means the chips at the bottom go out, but everything else kind of interweaves together, and then you've got a big plug in your system. That's very, very common in chips, and it's even more common in some of the agricultural materials. And that's a huge safety issue. You can't send a guy into a pit or a bin to try to break that out, because he's going to get swallowed up in that. There's several deaths a year you see in corn silos and things like that. So we focus a lot on working with some of the traditional industry. Leidig Systems is a good example. They make reclaiming augers for the wood industry and the biomass industry. And we've worked with them to custom design augers and that sort of thing to take multiple biomass crops, including wood chips. And they've been very, very effective because they have a sweeping arm and some other features that keep it from bridging and rat holing, and you don't have those plug issues that you would have otherwise. One of the other sides of this is storage, and that's another advantage that these short rotation woody crops, and really any wood, has over a lot of the agricultural materials as well. They're high in bulk density, and they can be stored outdoors. You know, you've seen stacker reclaimer piles of hundreds of thousands of tons of chips at a pulp plant. That's an advantage that wood has. A lot of the agricultural materials we can't store that way. You get too much degradation in the material, you lose too much quality. So they have to be stored dry. So wood does give you the flexibility from that storage side. But as I noted earlier, you have to work with that end user to make sure that they have enough storage. Most folks, and I don't want to throw off on anybody in the industry, but you would be surprised the number of folks that think you can go out and harvest every day of the year, that it doesn't matter what it does. In Tennessee, from an agricultural standpoint, in the window from November to the end of February, there are 53 harvestable days on average. It's less than half the available days. So you have to coordinate with your end user to make sure that they have enough storage on site that they can operate while you can't in the field. And so coordinating that volume of harvest makes a big difference to their success and to their overall profitability. We talk a lot about conveyance and handling of material with our customers as well. Even though we're a biomass supply chain company, we typically don't deal with the downstream processor. They handle that. We have focused a lot with them on just how do you handle material inside your facility. Do you use drag chains and bucket elevators and conveyors, or do you use a pneumatic system and move things around by air? At our pre-processing facility that we have, we actually use pneumatic conveyance. We blow everything around with air. Anytime you deal with biomass, particularly dried biomass, so once the wood has been dried and you're getting ready to hammer mill it, or after you've hammer milled it, dust is a huge issue. And believe it or not, you can inject dust, wood dust, into an engine and run an engine off the combustibility of the dust. It is very, very explosive for those of you that have been around the wood industry. Any of the biomass crops are. So that dust control, the cleanliness of your system, really drives a lot of your health and safety. We spend a lot of time with OSHA and our state air permit agencies to try to figure out how we best handle that dust, how we design systems to make sure that that's effective. One of the things that seems really simple that a lot of people can't seem to get is just regular housekeeping and maintenance. We worked with a customer that had a wood front end accepting wood chips, actually pine wood chips, and we toured their facility on a consulting basis to help them with some operational issues. And one of the key things that our engineer pointed out to them was that they had piles of dust and wood building up at the end of their conveyors. Where the conveyor belt made the rotation to go back up the conveyor, there were just mounds of dust and debris around those. You know, and that's an easy place to fix a problem before it happens. Sure enough, 6 days later they had a fire in one of their conveyors. It caught because of the friction in one of those piles, and it actually burnt through an auger system. So some huge issues. And it's just making sure that they understand all the risks associated with the feedstock. So that regular maintenance is really important, as is dust control and mitigating those risks at the end of the facility. You know, kind of one of the final take-home messages, and Bill told me to be short because I'm between you and lunch, I think. Or I guess Brent is actually the one that's between us and lunch. But, you know, feedstock cost, including the logistics, so delivered feedstock cost to the gate of a biorefinery, is typically about 50% of the total cost of the output product. So if you're looking